Hey everyone, welcome back to Physics in the Flesh, Newton's Third Law, Part 2. This video 65 is a continuation of the previous problem in video 64, again on Newton's Third Law. Okay, so we had three blocks on a frictionless horizontal surface. They're in contact with each other. A force F is applied to block A, which has mass ma. Okay, so in the previous video, we drew free body diagrams for all three blocks, and we then determined the acceleration of the system. And we found the acceleration to be A equals F over ma plus mb plus mc. Okay, so that's to catch everyone up to speed. If you didn't catch parts A and B of the video, be sure to click on video 64 and then come back and continue on. Okay, so part C of the problem asks us to determine the net force on each block. Okay, so let's get into that. To find the net force, according to Newton's second law, net force is equal to the product of mass and acceleration. Okay, so for example, for block A, F net on A is going to be equal to the mass of block A times acceleration. Now, the acceleration of block A is the same as the acceleration on the system. So the acceleration we found in part B is what we're going to plug in here. Okay, so the acceleration we found was this expression right here. Okay, this expression right here. So we're going to put this expression times mass of A, and you are going to get ma F over ma plus mb plus mc. Okay, and that is F net A. Okay, so there's the net force on A. And the net force for B and C actually follow very similarly. So F net B is equal to the mass of B times the acceleration. B is also accelerating at the same rate. So we just replace acceleration with F over the sum of the masses. So MB F over MA plus MB plus MC. And of course, the last one is going to be F net C, same thing. It's going to be now MCF over MA plus MB plus MC. Okay, so that answers part C for you. Okay, now going back to the original problem, part D asks, determine the force of contact that each block exerts on its neighbor. Okay, so the fact that they're exerting forces on each other, that's due to Newton's third law. So what D is asking us to find is in fact the force of block B on A, the force of C on B, the force of A on B, and the force of B on C. Okay, so that's what we're going to be looking for here. So let's get started on that part. So for part D, I'm going to go ahead and start with mass mc first because it has the lowest number of forces acting on it. Okay, so I'm going to look at the net force on block C. If you look at the free body diagram for block C, the net force in the x direction is just FB on C. Okay, we're not dealing with the y here. We know the net force here is 0. In the x direction, the net force is equal to FB on C. That's the only imbalanced force. So F net C equals FB on C. Now, F net C, we just found that. F net C is MCF over MA plus MB plus MC. So that is what FB on C is equal to. Okay, so let's do that over here. FB on C, that's just going to be this because that's already the net force on C. It's going to be MCF over MA plus MB plus MC. Okay, so there's one of the forces. Now again, according to Newton's third law, we just found FB on C. Okay, that's this right here. This is determined, so it's done. But according to Newton's third law, equal magnitude, opposite direction, action-reaction forces come in pairs. Okay, so that's going to be FC on B. Those two have the same magnitude, opposite directions. Okay, so by knowing this, we can actually state the other one as well. So we can say that, you know what, FC on B, and notice I'm not putting the vector symbol, so I'm simply indicating the magnitude. I don't need to put any positive or negative signs here. It's going to be the same magnitude, MCF over MA plus MB plus MC. Okay, so these two were really straightforward, really simple. Okay, they just came out like that. Now, the next one, we're going to look at MA next. MA is going to require a few more steps because there's more forces acting on it, but it's going to be pretty straightforward as well. Okay, we're going to start with the same first step. We're going to say F net A is equal to, and then, well, taking a look at the free body diagram for mass A. Okay, so taking a look at this, we've got in the positive direction F and the negative FB on A. So we're going to do F minus FB on A equals F net. F minus FB on A. Okay, now this is what we're looking for, FB on A. So I'm going to bring that over to the left, making it positive. F net A comes over to the right, becomes negative. Okay, so FB on A is equal to F minus F net A. Now I think, and I hope you can already see where I'm going to go next with this. We already know what F net A is. We found that earlier in the previous part. F net A is this expression right here. MAF over MA plus MB plus MC. So that is going to get plugged in. So equals F minus MAF over MA plus MB plus MC. Okay, now your earlier understanding of mathematics should tell you at this point that in order to combine these two into a single expression, I need a common denominator. Okay, and while the F simply has a denominator of 1, okay, we're going to have to match the denominator to what we have here. MA plus MB plus MC. So the next part's going to get a bit long here. Okay, so equals. Now, if I put the common denominator of MA plus MB plus MC down here, then I have to multiply it as well. Therefore, you're multiplying F by 1. So we get MA plus MB plus MC times F over MA plus MB plus MC. So this expression, simply replace the F, right? Because if you cancel out these two, you get 1, because these two are the same, you're left with F, which is what you have here. This is our common denominator. Minus MAF over MA plus MB plus MC. All right, so now our denominators match up. So I'm going to combine these two, write it as a single expression, and simplify. The numerator, I'm going to simplify too as I combine the denominator. So in order to simplify the numerator, I need to expand, right? So I've got an F out front. So this gets multiplied to every term inside. So we get MAF plus MBF plus MCF. And then you see that minus there? It's going to be minus MAF. All over the common denominator of MA plus MB plus MC. Okay, so we've got a positive MAF here and a minus MAF here. Those two cancel out, become 0. Okay, so my next line is going to be this, which equals MBF plus MCF over MA plus MB plus MC. Okay, hopefully this sticks out to you at this point. We've got F in both terms, so we're going to factor that out, simplify it yet again. We had to expand this in the first place so we could cancel out the MAFs, but now that we've canceled those out, we have a simpler expression. You can take the F out. So now this is equal to F MB plus MC all over MA plus MB plus MC. You know what, let me just cross that out. Equals, and we were looking for FB on A. So there is FB on A. Now notice, even though the steps were longer, the problem was actually pretty simple to begin with. We started with the same first step. We just did F net A, the net force on the object. We rewrote it in terms of the actual forces. You know, I had already found F net A, so I replaced that here. Okay, and I isolated for f, b on a. And then after that, it's a simple math problem. Common denominator, expand, simplify, factor. Okay, so here we got f, b on a. And you know the next part, the easiest part, to find the last force, Fa on b. Newton's third law says these two have the same magnitude, opposite direction. So for magnitude, it's the same. Fa on b equals F times mb plus mc over ma plus mb plus mc. Wow. Okay, guys, so that's it for this video. That's all you can do to simplify it. I hope you liked it, and if you did, be sure to click that like button and subscribe to Physics in the Flash so you never miss a physics video from me. I post every weekday at 12 noon, so be sure to be on Physics in the Flash at that time to catch the latest video. Enjoy the rest of your day, guys, and I will catch you in the next video.